So last class we did started our discussion on CAD modeling, how to create a CAD model for additive manufacturing process. So if you remember, we started our second module. So second module is about data processing steps for additive manufacturing. So you have 8 steps which has to be followed sequentially. The first step is CAD modeling, then conversion of your CAD into STL file. Then you identify the appropriate part orientation. Then based on the part orientation, you generate a support structure. That is the fourth step. The fifth step is to slice the part with the support into n number of 2D contour through slicing procedure. That is fifth step. Sixth step is for each sliced contour, you have to create a tool path. That is sixth step. And the seventh step is once you set all the process parameter data, you can transfer the data to the appropriate machine. That is production or fabrication of a part. Then the eighth step is removal of part from the machine and do some post-processing to improve the finish, or you can remove the support structure. So these are the sequence of steps which has to follow in additive manufacturing process. Among these 8 steps, the last two, production and support post-processing, is a physical, experimentally done, and the remaining 6 are done virtually. So to start with this, in the last class we did discuss about the first step, the CAD modeling, how to create a CAD model for a given component. So there are different ways in which you can create a CAD model. The preliminary way is to create a CAD model by using a software. That is a forward engineering approach. And the reverse engineering is you may have a existing component, and according to the component you have to create a profile, or same component you have to recreate it. So in that case you have to go for reverse engineering. Again, reverse engineering can be contact and non-contact. Contact would be CMM, coordinate measuring machine, and non-contact you have a same CMM with a laser setup, and apart from that you can also use MRI CT scan for biomedical based images or some internal images. So this is what we did discuss. So what is the difference between forward engineering and reverse engineering? Because reverse engineering is very critical in our case. Most of the component which we are fabricating in additive manufacturing process requires complex features. So most of these features are done through a reverse engineering process. Either they extract the feature from the existing component, or they will mimic it. So all additive manufacturing process require data from reverse engineering process. So in forward engineering, you may have a requirement. So in forward engineering, the requirement is a dimension. You'll be having a dimension of a model, different view of a dimension, a different view of a model with a dimension. Then using the dimension, you create your design through a CAD software, because you can refer the dimension. You can create a 3D model. Then the 3D model can be transferred to the machine for fabrication. After fabrication, you will get a physical part. So that is forward engineering. In reverse engineering, it starts from the bottom. Already you have a physical part. Part is available with you. So from physical part, you collect a data. So by using a CMM or a non-contact laser-based reverse engineering technique, using the part, you are going to collect data. Then the collected data is subjected to processing. You have to process the data, because the collected data might be not a direct 3D CAD model. So from the data, you have to process the data to get an appropriate CAD model. So that will be your requirement. So that is the difference between forward engineering and reverse engineering. Reverse engineering starts with a 2D sheet, and finally you are going to end with a physical component. In reverse engineering, you may already have a physical component. From physical component, you have to create a two-dimensional information or CAD information. So that is a major difference between forward engineering and reverse engineering. One of you can put a reply. Is it visible, the reverse engineering and forward engineering flowchart? Slide
Yes,
of
sir.
reverse.
Yes, sir.
So maybe after 10-15 minutes, we will have a short polling process. So I'll post a question based on the topic which we have discussed. You have to answer for that, right? So that is a major difference between forward and reverse engineering. and most of our additive manufacturing process required reverse engineering. So, just this flow will give you the overall view. So if you have a component, that is if you have a component, do a reverse engineering. Using a reverse engineering, you can generate a CAD data, then transfer the CAD data to RPT. RPT is rapid prototyping and tooling. That is a rapid manufacturing process. So give the data to the machine. Machine will read the data and it will produce the data in layer by layer addition of a material. So after printing, you may get the real component. So this is one way. The forward engineering is you have a dimension. Based on the dimension, you create a CAD model. Then using a CAD model, you have two options. So you can transfer the CAD model to additive manufacturing to get a component. CAD model can also be transferred to traditional manufacturing. Computer assisted traditional manufacturing is CAM, computer assisted machining like CNC, VMC, vertical milling center, lathe with computer assistance. So computer will read a data from CAD and automatically it will generate a program for machining activity, right? So that is a CAM process. So this play a reverse engineering play an important role in CAD, CAM as well as additive manufacturing process. When you have to go for a reverse engineering, for example, if the data for a manufacturing is not available, for example, uh, you might have missed the drawing sheet, or it was fabricated long back, so you do not have a data for that particular component. The product is also no longer. So if the product is not available with you, then you can go for a reverse engineering. Product in the sense multiple product. If the production have been stopped, then definitely you may not have a relevant data. So in that case, you can go for reverse engineering. Sometimes there may not be any data also. There may not be available. The sculptures which I have shown here, these are the CAD model of a sculpture. We do not have a proper thickness, diameter, fillet radius for this component, right? It is also not feasible to represent in 2D. So in that case, there may not be existence of data or the model or sculpture from animation. Sometimes you can also go for reverse engineering for quality control. You have a component which is designed in a CAD model, and the component is fabricated using some manufacturing process, right? So after manufacturing, using a reverse engineering process, you measure the data and you merge the measured data with the CAD data, because CAD data is a perfect dimension. You may not consider any environmental issue or machine malfunction in CAD. If you want to have a diameter of 10.0378, it is feasible in CAD. But manufacturing exactly 10.0378 is not feasible in manufacturing process, because there are a lot of other issues associated with the physical manufacturing. So there might be some tolerance variation. So you fabricate a part, then you do a reverse engineering for the available part. Physical part, you measure the data. From the measured data, you create a CAD model. You know the original CAD model, merge the measured CAD model with the original CAD model, it will give a deviation. So if the deviation is within the tolerance what you are mentioning, then it is fine, not an issue. So reverse engineering is also used for some quality control application. In certain case, reverse engineering is also used in scam related. If there is any crime scenes you want to record, maybe at the time of investigation you may miss. So some places where reverse engineering is also used for successful crime investigation. You record the data virtually by using a non-contact measurement. Later, for investigation person, you can go through the recorded data. If there is a feasibility to identify uh, some okay. So so that could be investigation and crime could be another opportunity for reverse engineering, where if you miss a certain thing in the crime scheme, later you can identify it by using the recorded model, right? So that is all about the importance of reverse engineering. So reverse engineering can be done by two methods. One is contact method, the other one is non-contact method. This is very critical. Let us see the difference between contact and non-contact method. In contact method, you are going to put a probe onto the surface. For example, I would like to know what will be the dimension of the part which is shown here, right? So to understand the dimension, I'll take a probe and I'll take some point as 0, 0, some point which is out of a part. I will record that point. I'll touch the point and make sure that that point is 0, 0, so that I will record it as 0, 0, my origin position. From origin position, I can gradually move the tool tip and I'll touch at certain place. So how long I have moved, because I might be using some drives to move that probe, right? So how many units I have moved in x-axis, how many units I have moved in y-axis get recorded in the drive, because without a drive rotation the probe cannot move. The movement can be done either manually or by using some automation method. So once it touch, it will calculate the original position and the current position. So from this, it can easily calculate a distance, how much it have traveled. If this is 0, 0, this point might be 2, 2. So this data is transferred to the machine, that is through a CAD software. It will get generated in a CAD environment. So whatever the value you have identified in the movement, so that value get transferred into the CAD model. Then again you move the probe to the next point. So here x is same, y value is same 2, but x value from 2 to 3. So this point is 2, 3. This point is 3, 2. The third point is 4, 2. The fourth point is 5, 2. So as I touch multiple position, I could be able to measure the distance between the previous position and the current position, and all those positions will have a reference to the home position which you have touched earlier. So you can easily measure the dimension using this method. This is contact method. Non-contact method, you no need to touch, because when you touch a component you have some issue. For example, if the component is very fragile in nature, if you touch a component, the component tend to deform. So instead of 2, 2, because of the deformation in a part, you may be getting 1.99, 1.99. So that will not give an exact value when you touch a component, because of the deformation associated with the part, as well as the deformation, because this rod will also tend to bend. If you apply a load, definitely it will have a minor buckling. So that buckling will also add into the tolerance error. So that is the issue in a contact-based CM, contact-based reverse engineering. In non-contact based reverse engineering, what you can do, you can pass a laser, and the laser will pass onto the component. It will reflect back. So you know the time taken to travel from the original source to the part, then from the part to the detector. So by using the velocity of light value and also the time taken to come back, you can easily determine the distance. So this is the non-contact. Now what is the issue in non-contact method? Non-contact method, the features which are parallel to the ray will not get captured. If you look here, the ray will fall onto this surface and it will come back. Similarly, you can expose the ray to the multiple point, you can collect the data. But the feature which are parallel to the ray direction, it will not get into the scope of measurement. The ray will not fall into this surface. Unless otherwise you have to rotate a component, or you have to rotate a laser, or you should have a multiple laser. This side I should have one laser, this side I should have another laser. But if the part is very complex, can I have laser in all direction? That is very difficult, right? So you need some processing method to read the data in all surfaces. So that is one critical disadvantage in laser based. And apart from that, when you compare probe and laser, laser will be much cost compared to the probe. So the cost and requirement of processing of data with the parallel surfaces is some of the disadvantage in non-contact. In contact, wear of a probe, bending of a probe stem, and fragility of a component which you are measuring. And sometime you may also have an issue over a period of time. This probe tip, generally made of diamond or ruby, still when you touch at multiple points, this also tend to veer, so that will add some additional inaccuracy into the measurement. So these are all the problem with associated with contact based. Another important problem with non-contact phase is the non-contact based work based on reflectivity. So if the component is highly reflective in nature, and if it is not allowing to observe, or if it is not giving a proper reflection, then again you may have a issue. So there is an issue in terms of reflectivity, but in that case you can coat a component with some additional material, so that the reflectivity problem can be eliminated. So what I did mention, the deflection of a probe. This is an exaggerated view, but still, when you use a probe-based method, especially at the edges, especially if the component is very hard, the probe will tend to bend. So you are supposed to record this point, and because of the bending, the dimension what you have recorded might change. So that is about the contact and non-contact method. So how to process the data? Because as I told you initially, in all reverse engineering process, you have a CAD model, and the CAD model has to be processed to get a three-dimensional part. So you should process the data in a specific manner to get a 3D shape. That is data processing for reverse engineering. CMM I did mention. So CMM you might have studied in metrology. So traditional way of measurement is done using a vernier or screw gauge. If the part is somewhat complex, then CMM machines are used to do a measurement. So here it based upon a probe. CMM stands for coordinate measuring machine. So this is the triangulation method which I mentioned earlier. So in non-contact based reverse engineering, you have a source which will pass a laser, and the laser fall onto the object. Again, the reflected light will come back. There will be a detector to detect this. So it is like a simple trigonometric procedure. If you know the distance, you can calculate a time taken. If you know the time taken and velocity of a light, you can calculate a distance. So there are different ways measurement, time difference, triangulation. Triangulation is based upon the, you know, the angle between two point, that is the laser point and the reflective point. So these are the different way. One is difference in phase will help you to identify the position of a point. The second one is time it take to reflect back. The third one is, you know, the predetermined distance, then using the distance and velocity you can calculate a time. So these are the different method, and all this method are triangulation method. Using this triangulation you can calculate your position of a point in a surface. So if you expose the laser to multiple point, you could be able to identify multiple point on the surfaces, and if you join those point, you will get a contour. So this has to be repeated for all surfaces or all the contour. Then if you merge all those contour, you will get a 3D component. Okay. If you look into the source laser can be of different type. It could be a point source laser, or it could be a line laser, like you have a line of ray which falls onto the component, or point line. Each and every time it falls into the component, it come back. And you can also have a coded laser. For example, it is like a inference pattern where you may have a predefined pattern. When you project such a pattern onto the component, because of a change in shape, your pattern shape also, if you project as a circle, as there is a change in pattern, it might be elliptical one, and the amount of change from original shape to the observed shape will tell you what could be the profile of a component. So that is another way in which you can do a reverse engineering. Okay. Now we will come to the, so far what did I discuss is we did discuss about how to do a CAD modeling for additive manufacturing process, and in that there are two way in which you can do a CAD modeling: traditional modeling and reverse engineering, forward model and reverse engineering model. Forward modeling is the process which you follow in CAD software. Any CAD software, using a dimension, you create a CAD model, right? In reverse engineering, from physical data, you'll be creating a CAD model. And most of additive manufacturing process take data from reverse engineering, because we are going to work on complex region, complex features. So in that case, reverse engineering is very much useful. Under reverse engineering, you have two types. There is contact reverse engineering and non-contact reverse engineering. So contact has non-contact and contact has certain pros and cons. So that we did discuss. And in non-contact, you have three types of laser point. It could be a point source of laser, line source of laser, and sheet source of laser. So obviously, if you move from point to line, line to sheet, the cost will also increases. But at the same time, your accuracy and data capturing will be enormous if you use a sheet of laser compared to point laser. In point laser, each and every point on a surface, you have to pause and measure. So time taken to complete a measurement and data processing will be tedious in point source. So that is what we did discuss so far. And now how the measurement is converted into a CAD model, because what we have discussed so far is only about how to do a measurement, what are the different way to do a measurement, and how the measurement construction equipment will be having, what are the parts associated with construction of measurement equipment, right? But how the data are transferred. Once you pass a laser onto the component, you are getting some information, that is a point, how the points are converted into 3D data. So that is what we are going to discuss for next 10 minutes. So this is data processing for any reverse engineering method. So it starts with the data acquisition, registration, data pre-processing, polygon mesh, segmentation, surface fitting, and surface model generation. So what are the steps indicate? These steps indicate how to transfer the laser source data into a 3D CAD model. So this is very critical, and you have a lot of scope to do research or project work based on reverse engineering, how to manipulate the data, and how the data can be transferred into a CAD model, which is readable by additive manufacturing machine. Because without CAD, there is no point of going for additive manufacturing. CAD is required for all additive manufacturing, and CAD is the input data. So how to create a CAD model from existing physical data through a reverse engineering technique. So first we will start with the first step, which is data acquisition, right? So data acquisition is using some method to acquire data. It could be a contact based CMM, non-contact based CMM, CT, MRI. So anything could be a data acquisition method. So as I have mentioned here, it could be a 3D laser scanner, MRI, CT scanner, ultrasound, or digital camera. So what equipment you are going to use for acquiring data? So that is a preliminary step. So in this example, I am going to explain the complete steps, that is 6 steps using non-contact by using a laser-based method. So if you look here, this is, B is the original model, and at the back of the image, you can see the laser source. Could you all able to see the laser source? So it has a receiver also. So the laser source falls onto the object, and it will come back. So there will be a receiver and source in the stand which is kept behind. So that is the data acquisition method, right? Now the second step is registration. So once I pass a laser light onto the component, it will read the position, and I have to register the position, right? Obviously the light falls onto the component, it come back, so you know the distance. So that distance has to be registered in some database, right? So here we are going to do a registration in a CAD software. So whatever the data the laser measures, for example, it falls onto the component, and it will identify, based on the calculation, it will identify that this particular point is at x2, y4, and z6. So the point which the light measured now is 2, 4, 6. That is x, y, and z, because it is in 3D space. So now how to transfer this data 2 comma 4 comma 6 into a CAD data. So this data will be connected with a, database system where automatically it will read the data 2 comma 4 comma 6 will be read by the software, and that reverse engineering software will automatically pop up empty three-dimensional space in a sketch form, that is in 3D model form. And in 3D model form, automatically it will create a point. Whatever the data you measured on first point, so how we do point in CAD software, we will open a software, we will go to the sketch. In sketch mode, you could able to see the uh, origin position at the corner, right? From the origin position, you can take some x value and y value, and based on the intersection of x and y, you can create a point if it is a 2D. In 3D, from origin, you have to take some x, y, and z. So in that place, you have to create a point. So how we do manually, that is replaced by automation method. So that is the purpose of reverse engineering module. So all CAD software have a separate reverse engineering module. So if you have a license for reverse engineering model, then using the license, you can interface with the measurement system. So whatever the data read by the measurement system, it get transferred as a Excel sheet data, and the software will read the Excel sheet data line by line. And for each line, the data will be some X value, Y value, and Z value. So that X and Y Z value, it will read and it will plot a point automatically into the 3D space. So it will be done automatically. You no need to read the data and create a point, because sometime you may end up with lakhs of point, so you cannot create those many lakhs of point manually. So there we require a simple automation. It is nothing new. Even if you go to YouTube, you can see how to read a Excel data and create a point in SolidWorks. So if you want to create some point, random point, you whatever the point you required, you type in Excel itself. Then there is an interface in SolidWorks where it will read the Excel data and create a point accordingly. So that is what basically done in registration process. Now, in registration, one critical point which I want to tell you, because most of you might not have studied CAD, as I mentioned earlier, if you look into this image, you have a source, and there is a car which is kept on the opposite side of a source, laser source, and the ray falls onto it. Now, you cannot observe the point of all surface in a single stretch. As I mentioned in the previous slide, there are some parallel feature. So if that is the case, what you have to do, either you have to rotate a camera, or that is rotate a laser source, or you have to rotate a part. So in this case, we are unable to rotate a part. So it depends upon the parts you are dealing with. So if the part is very simple, you can rotate an entire part. So you have to rotate an entire part and then do the measurement. But in this case, what is done is the laser source is rotated. For example, there are two images. The first image is taken when the laser source is at 0 degree, and the second image is taken when the laser source is at 45 degree. You know how many angle you have rotated, and based on the same angle, again you rotate in counterclockwise direction, so that it will get merged with the original model. So this is what we are doing in non-contact reverse engineering. In non-contact reverse engineering, we cannot capture entire surface in a single stretch. If I want to capture my face, my profile of cheek, everything will get captured, but the nose surface, which is parallel to the camera, will not get captured in three-dimensional part. So in that case, I have to rotate a camera for some degree. Then I have to I have to capture the nose surface. So how many angle I have rotated? For the same angle, again, I have to do a rotation in counterclockwise direction for a CAD model. So when I do such a counterclockwise direction, it will get merged with the existing part. So finally, you will get a complete 3D part. So this is what data registration and transformation of object according to the rotations you have performed in a laser source. Sometimes it may also record some, so for example, there are some other part which are along with the part which we are subject to measurement. So that has to be removed. So that is pre-processing. If there is some additional data got captured, or if there is any minor features are missed, then that has to be done manually. So generally this is to avoid some additional feature which get captured along the measurement. Then you have to create a polygon mesh. So what is polygon mesh? When I do a measurement, I will be getting only a cloud point. It is not a surface, because at each and every region of a part are subjected to laser impingement, and the point where the laser impinged, the data point is created in a CAD software. So I have to convert a point into a wireframe model, then from wireframe to surface, then from surface you can get a solid model. So that is the traditional way, right? If you want to create a cube directly, you could not able to create. First you have to create 4 points, then you have to connect those 4 points by using a line. Then if you connect a 4 point, it will become a square. Then extrude the square, you get a cube. So how it starts? It starts with a point, then connect a point to get a wireframe model, that is your square. Then you connect the edges of squares to get a surface. Then you extrude a surface to get a solid model. So the same procedure will be followed in reverse engineering. So whatever the data you acquired and you have merged, it is a cloud point. It is only a point. So what you have to do is you have to connect those points into lines, edges. So the second image is a connected image, which I think. Could you all able to see the car image A, B, C, D? Is it visible to everyone? A, B, C, D. Car image is visible?
Yes, sir.
Okay. So if you look into A, it is only a cloud point, right? So if you look into the B, the cloud points are connected. So this B model, whatever the model I got in B, so that model is a third step, that is a fourth step, sorry. Fourth step. So first step is data registration, then data acquisition, data registration, then pre-processing to remove the noise. Then the fourth step is polygon mesh. So what does the polygon mesh will do? The polygon mesh will connect all the cloud point into a triangular connected surface. So how does it happen? It happen based on some algorithm. So to make it very simple, it will start with some random point and it will search for nearby point. So any point will have multiple point nearby, and it will search which point is very closer to the point which you have started. So it will identify that point as point 2 and original point as point 1, and between point 1 to point 2 it will create a line. This is also done automatically, because if you look into the car, you may have 20 lakhs cloud point. You are not able to connect all those cloud point by using a manual method. So algorithm is required. So that is the reason why we are paying much money for reverse engineering model. So it will select a point and it will search for nearby point, and it will draw a line between the original point and nearby point. So that will become a line. From that point, it will exclude a point where it has started. Then it will search for nearby point. So other than the point which it has started, it will search for another point which is nearby to the second point. So this, uh, once it identifies the nearby point from the second point, then it will draw a line between the second point to the third point. Then once it created a second line, from the third point, directly it will go to the first point. It will not search for any nearby point. Directly it will go for the first point where you have started. So that will become a triangle. That is called polygon mesh. If you look into the model has a lot of connected triangles. So these connected triangles are nothing but polygon mesh. Each and every points are connected as a wireframe model by a shape called a triangular shape. So how the triangular shapes are created? It will start with some random point, search for nearest point, draw a line. From the nearest point, you search for another nearest point, draw another line. From the third point, you no need to do any other search. directly go back to the original point, it will form a triangle. Then from that original point, it will exclude the remaining 2 points. It will search for third point. Then again from the fourth point, it will create a line. You will get another time. So this will be repeated. So you have a lot of search algorithm. You can also create some new algorithm to search, optimize the search, and improve the searching mechanism. So there are different way to create a search and do the polygon mesh. So that is what performed in the fourth step, a polygon mesh. So once you get a polygon mesh, the fifth point is segmentation. For example, if you look into this image, uh, segmentation, what it will create a patch of a surface. For example, each and every triangle will have a normal vector. If you look into the triangular patches, so each and every triangle will have a normal vector. So what is normal vector? The vector direction which is perpendicular to the face of a triangle. So it will have a group. For example, the angle which is between 90 to 91 degree. So it will identify the triangle which have a normal vector uh, between 90 to 91, and it will group all those triangles as a single surface. Similarly, if you look into this car image, so this is a front face, this is a side face. Obviously, the normal vector of a side face will vary significantly from front face. So obviously, this front face will form as a single surface, and the side face will form as a single surface. So how this is done automatically? This is done automatically by using a normal vector of your triangle. So the triangle which will have a normal vector within a given range. So that triangle will be merged together to form a surface. So that is the segmentation process. So normal point, it will create a normal point and it will create a connectivity. Then finally, that is in segmentation, it will start to create only normal data. Then those normal data are converted into a patch. So that is surface fitting and surface model generation. So finally, you are going to end up with a 3D CAD model, which is acquired from the existing physical model. So these 6 steps are very critical in any reverse engineering process. You have to determine the proper data acquisition system, and there should be a proper way to transfer the acquired data into a CAD cloud point. And if the cloud points are measured at multiple orientation, then you have to do a counterclockwise direction for all those orientation to get a smooth connectivity of a point. Then if there is any noise associated with collected point, that has to be removed through data pre-processing. Once you have finalized the required cloud point, using a polygon mesh method, you create a wireframe out of a cloud data. Then for each of the wireframe, because the wireframe is nothing but a connected triangles. So for each of the triangle, identify the normal vector and register the normal vector in segmentation. And based on the normal vector direction with a given range, you can form a surface patch and connect all those surface patch to get a 3D surface model. So this is what done in any reverse engineering software. If you could be able to do it manually, then you no need to pay. But since the lot of algorithms are involved in each and every step, so software have created a separate module for reverse engineering. For example, I can share some software. These are some of the software which you can use for reverse engineering: Rhino, Polyworks, Geomagic, Spider, reverse engineering tool, Rivworks, Rapid Form. There are many softwares available. Nowadays, we have some facility in mobile itself. So you place a model in a free space using a mobile phone camera, take an image and pass JPEG file into a software, some open source software. So the open source software will read those image file. From the image file, you could able to create a 3D CAD data. The steps involved in creation of 3D data is discussed now. So you can also create a 3D model of your own component by using your mobile phone camera. application is also available where directly from captured image using a mobile itself you could able to create a 3D STL model which is required for additive manufacturing. So I hope with this the first part of our data processing is over. How to generate a CAD model. So reverse engineering is very critical for CAD model generation, and with this session you may got a clear idea of how to do a reverse engineering for given component.